Hello everyone, this is the fourth video of 1.2 atomic structure. In this video, we'll be still looking at main shells, electron shells, and also subshells. In this video, specifically talk about which main shell has got what sort of subshells and how many electrons can go into each subshell, sorry. Okay, so this is where I want you to be looking at on the lecture note. So this is slide 15. Okay. So I have got this table drawn out like so, and I want you to do that as well. So I have got main shell numbers written, 1, 2, 3, 4. Now, back in year 10, I only told you to remember 2, 8, 8, 18, because that's a stable number and it works for the first 20 elements. But it's no longer the case if we are looking at up to element 30. Main shell 1, 2, 3, 4, the maximum number of electrons can fit into each shell can be determined if you did the calculation of 2n squared. So the maximum number of electron shell can be figured out if you did 2n squared, and n being either 1, 2, 3, 4. So you should be able to have for the first shell 2 as the answer and 8. So that's okay, that kind of conforms. Next is going to be 18 and 32. So they're the four numbers that you would have seen it, but I told you not to worry about using them. I told you to just stick to 2, 8, 8, 18. But now, if you remember, there were limitations in that kind of the rule of main shell and how electrons are positioned around. Using subshells can explain all those limitations and also things that the main shell notation couldn't really talk about. All right. Each main shell have got different subshells. You can have, let's change colors for first one. First shell only has S group, S block. Second period has S, P, and that's it. 2 subshells. Third main shell has S, P, D. And the fourth main shell has S, P, D, and F. Now, all the S subshells can have up to 2 electrons. So that's the maximum number of electrons available for S shells. So 2, 2, 2, 2. So S shell can only have up to 2. P block can have up to 6 electrons. D subshell can have up to 10. And F is gonna be 14. Okay. Now, if you can pull out a periodic table at the moment, have a look. Count how many elements are in each period. So if you look at the first period, so you would see hydrogen and helium. There are only 2. And what's the maximum number of electrons that can fit into first main shell again? 2. So, well, how many ever you add, total is going to be still 2 here, shouldn't it? How about second period or even third period? Second period here, it has lithium, beryllium, so 2 elements, and then boron, chlorine up to neon. So there are 2 and 6 elements. So there are 8 elements in the period 2, doesn't it? So altogether, second shell can have up to 8 electrons. Third shell, let's keep going. 2, 6, that's 8. And then if you add 10, you would get 18. Yeah. And if you can do adding these up as well, you would be looking at 32 electrons as well. 2 electrons in total. Yeah. Now, these numbers correspond to the addition of all these maximum number of electrons which can fit into subshells. That's not coincidence, because we are just looking at the sections within the shell, sections within the shell. So if you add all the electrons, the maximum number of electrons, it should add up to what we have been talking about. And how do we come up with 2, 8, 18, and 32? We were using this 2n squared formula. That was it. That's all to it, all to subshell notations. It's just breaking down one level into different sections. Now on the next slide, slide 16, you can find this. You can find this periodic table. So it's also breaking down elements in the periodic table into blocks. And this is also the reason why the periodic table is not a simple rectangular shape. It's got weird shape because the elements are placed in particular groups. And if you remember, how electrons are arranged and how many electrons are in each shell defines its property as well. So the marvel of all the scientists, all the chemists in the past have put together for this very reason. Say helium, lithium, sodium has only 1 electron in 2s shell. Or looking at element 29, copper, and down below you see silver and gold right below it. They all should have what? 9 electrons in the D shell, and because the D shell is gonna be half full. Sorry, it's gonna be always full because the electrons are shifted from 4s shell, which we will talk about later on. But that sort of tells you about why they have certain property. If you're asked which block does nickel live in, you can just say it lives in D block of the periodic table. How about arsenic? Yeah, arsenic live in P block, because you can find arsenic in 4p subshell. Or what is one of the heaviest metal that lives in a P block? You can say, well, bismuth or polonium, depending on what the definition of polonium is. But yeah, bismuth is definitely one of the heaviest metals that live in P block. So that's how those SPDF are used. Yeah. So, all right, this is the end of part 4 video in 1.2.